Hello, everybody. As Sarah said, I'm Emily Hopper at JW Player, and I'll be talking to you today about how we are tuning the models that power our video ad marketplace using feedback loops. So first, what is JW Player? We are an online video platform, which means that we help power the video for thousands of leading publishers and broadcasters who are playing video on the web or on OTT devices, for example. And we're actually the #1 source of video views on the open web. So we are using this big scale to build data products that really are helping our customers to succeed. So to give you a few examples, we have a recommendations engine that surfaces interesting and relevant videos to the end viewers to keep them watching. We have an article matching product that helps our customers identify the content in their media libraries that matches the articles that they've written based on the metadata of a given page. And we have a video ad targeting product, which is what I'll be focusing on today. And what this does is it tries to identify really high quality ad spots and connect those with advertisers who are prepared to pay more money for them. So why is advertising interesting? Well, it pays the bills. A lot of our content producers are monetizing their content using ad impressions. We have hundreds of millions of video plays daily, accompanied by hundreds of millions of ad impressions every day. And so that means we've got this really interesting view on the video ads played on the web, where we've got a lot of diverse content producers with these ad spots, and we can use that pool to match up really closely with what advertisers who we work with want for their campaigns. In order to understand this, I'm afraid we'll have to understand a little bit about how video ad auctions work. I promise I will keep this brief. So first, our video loads on our page, and this means that we know an ad spot has become available. So we send out bid requests for this ad spot to the advertising marketplace. They will send bids back, and whichever bid wins can place an ad against this media. Now, the advertisers will have told their partners in the advertising marketplace, which kind of ad spot they're actually interested in placing ads in. This is known as ad targeting, and it will inform which bids and for how much the advertising marketplace is making. Ad auctions also happen can also happen through the JW Player marketplace. And that means that we can make use of the additional information we have on what's going on as the video player to identify better ad spots. So all of the bid requests that are coming from all of our media with all of their various potential ad spots come to us, and we decide whether to pass them as targeted bid requests to the advertising marketplace. So that means that we think that this particular ad spot is going to match up to the requirements, the targeting of a particular advertising campaign we're working with. And we'll send the others, anything that doesn't match that targeting, as a plain old bid request. Now, of course, we're still going to get bids back from these other bid requests, but we hope that we're going to get higher bids back on the targeting bid requests because the advertisers have this guaranteed quality of these ad spots. So what is an advertiser actually looking for in this targeting? There's really two main dimensions that they're working across, and one is the context of the video. And I should be clear, I'm talking about the context of the video, not, for example, the demographic characteristics of the end user. We don't deal with anything like that. So this might actually be something like the geographic location, what the content of the video is. And this is really important because as an advertiser, I only want to place ads in front of people who might buy my product. So if I'm a company that sells gardening supplies in Canada, then the people who I think are going to buy my product are the ones who are based in Canada, and they might be more interested in it if they're the kind of people who are watching home and garden videos. I also maybe want to be sure that this video is brand safe, that I'm not going to tarnish my brand's reputation by having my ad play just before it. All of this information is known as soon as the video player is embedded on the page. So we can very confidently say to the advertiser, yes, this ticks all of your boxes. We think this is going to be a great place for your ad. However, advertisers also want to target specific performance goals. So that is, how much is the end viewer engaging with the ad? Is the ad actually visible to them while it's playing? Is the ad going to be completed by the viewer? And this, of course, is not known until the ad actually plays. All we can do is predict how we think the ad is going to perform. So let's get started from where this project with the feedback loop started off. Our models are kind of based on two main types of data. One is historical. And to explain this, let's think about ad completion rate. So we have this ad for milk, and the advertiser has a hypothesis that if the viewer is watching this ad to completion, they're much more likely to buy the product. So they say they want 70% of these ads to be watched to completion in order to pay a good price for it. Now we have a hypothesis that the thing driving this ad completion rate is actually the quality of the media that it is being placed against. So if the media is really interesting, people are actually going to make it through the whole ad because they really want to watch the video at the end of it. So for example, this media might have a 93% of the ads placed against it historically might be completed because everybody's super psyched to find out what's happening with these cows. And this will be different from media to media, with the media itself being the causal factor. So you can see, for example, this media is presumably pretty boring, as only a third of people actually make it through the ad against this media. So we make a model that says the probability that an ad will be completed on a given media is equal to the historical ad completion rate against that media. The past is the key to the present. But can we do any better than that? So we said against this media, only a third of ads are going to get completed. But can we know if this particular ad spot against this particular player of this media is going to be one of that 30%? Well, we can get pretty close to this using real-time signals available to us uniquely through our player to predict the specific ad spots that we think are likely to be completed using a logistic regression model. So out of these 9 potential plays of this media with 9 potential ad spots, we're hoping to pick out the 3 that are going to be completed, or to identify those. So I've been talking about probability so far, but what we actually want is a binary. Do we send this ad spot as a targeted ad spot to the advertiser or not? And to convert those, we're going to use a heuristic where we set the decision threshold of our model to the desired performance. So that means if I'm a company that is targeting a 70% ad completion rate, we're only going to flag the ad spots that are on media with at least 70% historical ad completion rate. So these 2 circled in red, for example, and at the ad spot level with at least a 70% predicted probability of that particular ad being completed. Of course, there's no free lunch. There is a trade-off, and that is that the better we want these ads that we're passing to perform, the fewer ads we can pass. So here I'm showing for a bunch of our media, what the historical ad completion rate is. So you can see that a bunch of our media have pretty high ad completion, and then there's another cluster around this level of ad completion rate historically. And if we're using that historical ad completion rate as a threshold, then this is the number of ad spots that are possibly available to us, just filtering on that. So you can see that as we increase that threshold, we massively drop off the number of ad spots available, especially at these much higher ad completion rates. So I said we were setting the decision threshold equal to the desired performance. So say this is our desired performance in this dashed line, then we'll have this many ad spots available to us. However, as you've probably seen, this is not the best we can do. If we're integrating over all of these media that are above this threshold, we're actually going to overshoot the ad campaign goal up here in this star. And what we want to do is to exactly match that campaign goal, and to do that, then we can set a much lower threshold, and we can really increase the number of ad spots that are available to us. And it turns out advertisers really only care about meeting, not exceeding their performance goals. And they care much more about the number of ads they can put in front of people. So they care about this number of ad spots or the reach of their campaign. So this is where the feedback loops come in. So let's just go over feedback loops really quickly. Say we have some system. It's going to have some inputs, it's going to have some outputs. And hopefully we're monitoring those outputs. And we can use our observation of the output of our system to adjust the inputs. Now, typically, we might actually have a target, which is what we want, which we use to inform the settings, which are the things we can actually change about the inputs of the system. And we use the difference between what we observe of the outputs and what our target is to make adjustments to those settings. So an example you may be pretty familiar with is cruise control. And in this case, the target would be the set speed of the speed you set for your car. The output would be the actual speed you're going, and the setting is going to be how to press that accelerator pedal is. And by monitoring your actual speed, then your car knows whether it needs to, your actual speed relative to the set speed, then your car knows whether it needs to pull off the gas or not. In the context of the JW Player Marketplace, it looks pretty similar. So we start off with an ad campaign's ad completion goal. This informs the decision threshold of our models. As I said, we start off with that heuristic that these two are the same. It goes into these models, which are deciding which ad spots to pass to an ad campaign, and spits out the ad spots that are going to be passed with the targeting. And then we can measure the performance of the ad spots that we send out with targeting and use that to feed back into this decision threshold based on how different that is to our ad campaign's actual ad completion goal. So this is an example of one of our feedback loops that is in flight. So this dashed line here is showing the target performance, the target ad completion rate for a particular ad campaign. And the red line is showing how those ad slots that we passed are performing. And we can look at this as relative. So what is the difference between the ad performance and the goal here? And what's happening is that we look at this difference and we change the decision threshold on our model based on how it's doing. So here you can see that we're overperforming our goal with these red bars here. So this blue dot shows how we change the decision threshold in response to that. So it's going down and down. And then we have this kind of wacky day where we do really badly. So we shoot that decision threshold back up again. But then, of course, now we're massively overperforming. So we shoot that back down again. And then it stays pretty stable over here. So again, here the target is our ad completion rate as set by the campaign. The output is the ad completion rate of the ad spots that we're passing to the campaign. And the thing that we're actually able to change about our system is how strict the decision threshold is. I should say this is a feedback loop for one particular campaign. We actually have thousands of these in flight, which are individually tuning our models, each of our models for each of our campaigns. And what does this actually do for us? Well, it now means we can much more precisely control the performance of the ad spots that we're passing to our advertisers. So you can see here in purple, I'm showing what the performance would have been without the feedback loops. And in general, we're outperforming the campaign's goals by as much as 10 to 15% often. In this red hump, that's the performance of our campaigns with a feedback loop active. And you can see it's really tight, pretty tightly centered, close to 0, where 0 would be absolutely optimum, matching our campaign's goals. And more significantly, this means that we massively increase the number of ad spots that we're passing to our advertiser. So you can see here that we get almost 2 times as many ad spots using this feedback loop, because we're able to dynamically adjust that decision threshold and match the performance that our advertisers actually want. And this becomes even more dramatic if you look at it in terms of how strict the campaign's performance goal is. So the stricter the campaign, the more significant this effect is, with this, again, like twofold increase for this pretty strict campaign, these pretty strict campaigns up here. Now, unfortunately, model output is not the same as reality. So this graphic I showed to you before, this is what an ad auction looks like using the JW Player Marketplace. But how it should have looked is there's a big black box over the advertising marketplace outside of JW Player. We do not have a ton of oversight into what's going on here. And in fact, it can often be pretty different from what we suggest to the spots that we're passing to the advertising marketplace. And that's because the advertisers may not be bidding on all of the spots that we pass them, but they also may not be winning every auction that they're bidding on. And so this is kind of a big question mark that we also can't monitor very carefully because it's outside of our ecosystem. And what this leads to is discrepancies between the model output and reality. So let's take it as given that the feedback loops I've already talked about are doing a stellar job. The ad spots that we're passing to the advertising marketplace are exactly hitting their goal. So 0 on this graph is exactly hitting the goal. This is and then we're showing the difference of the performance of the ads actually placed by the campaign versus the performance of the ads that we are passing them. And so here, the campaign, for whatever reason, is happening to place ads on ad spots that are more likely to be completed. And then over here, as it's undershooting, then the ads that it's actually placing on ad spots that are less likely to be completed relative to the ones that we're actually passing them. So you might think, okay, well, this is the feedback loop you talked about, and there's an easy fix here. This thing that we're measuring is the performance of the ad spots that we're passing. But clearly what the campaign cares about is the ads that they're actually placing, right? So surely we can take, these are the targeted ad spots, those feed into the ads placed by the campaign, and then we can measure the performance of the campaign's ads and use that discrepancy to feed back into the decision threshold. However, as I said, which ads are placed is kind of a big black box. There's a lot of factors going on here that we don't have insight into, and we don't have control over. And so trying to do a feedback loop like this is much more difficult, and we worried that this might be prone to instabilities. And so we didn't want to do this. Instead, we set up this cascade of feedback loops. So here is that same feedback loop diagram that you know and love by now, but we have this other feedback loop that is sitting on top of it. So here we start with the ad campaign's stated ad completion goal. That feeds into the ad marketplace and says which ads, controls partly which ads are going to be placed by the campaign. And we can measure the performance of those campaign ads, the ads placed by that campaign. And then we can use the discrepancy between that measured performance and the stated performance to create an adjusted ad completion goal. And then this is what feeds into our inner feedback loop. And we close the circle because due to our adjusted ad completion goal, the decision threshold is going to change. So which ad spots we're sending out targeting for is going to change. And we hope that the ad spots we're sending out targeting on is going to play a big role in deciding which ads are actually end up being placed by the campaign. So this is still in progress to build this cascade of PID controllers, of feedback loops. And there is an outer layer where the target, again, is the ad completion rate goal set by the campaign. And the output is the ad completion rate of ads that are actually placed by the campaign. where, as we already discussed, there can be discrepancies depending on what the campaign decides to bid on or actually succeeds in winning the auctions of. So here I'm showing similar graphs to what we were looking at before, but this time the output of our feedback loop is the performance goal, the adjusted performance goal, so ad completion goal. And you can see that as the campaign continues to outperform what we want, then we the performance goal that we're aiming for tanks and tanks and tanks and tanks until this point where suddenly our campaign starts underperforming, and then it rises back up and steadies out. And you can see as well, when it goes back to what we expect, that actually requires another adjustment, because the beauty of these feedback loops is they adjust to whatever the world looks like at the moment, right? There isn't this like preconceived notion of zero being important. So the settings that we're able to alter here are the adjusted performance goal. And we use that as the target for our inner layer now. So now this black dashed line, which was previously flat, that single performance goal set by the campaign, looks like the adjusted performance campaign goal output by our previous feedback loop. And you can see that we are, with the bars, there's some discrepancy in the simulation between the goal and reality, and that is also playing into the decision threshold. I should say this looks a bit odd, because what you can see here is that as the performance goal is tanking, we actually hit a decision threshold in the simulation of 0. So this is our base rate performance across our network, for example. So to conclude, the marketplace that we've built at JW Player benefits both advertisers and publishers. So the advertisers are able to make use of our unique data insights to target the specific ad spots, which are watched by the right people in the right places, both by context and also by how engaged we think the audience is going to be. The publishers, in turn, are getting much more ad revenue because the advertisers are willing to pay more money in order to get this guaranteed quality of ad spot. And JW Player is making it all happen, maximizing the number of high-quality ad impressions that are available by using our feedback loops in combination with the real-time and historic models that we use to power all of our decisions. So thank you very much, and I would love to take any questions.
Thank you, Emily, for this interesting talk, and we're happy to answer any questions.
Rad.
You're back.
I'm back. I pressed a button.
Okay. Yes, we do have a question.
Yeah, so this is actually batch processed. In order for a feedback loop, the way that our feedback loops work, it assumes a discrete time interval. So you have some time interval, you measure what happens and the discrepancy over that time interval. Depending on how long that time interval is, you weight the difference accordingly. And so in that way, it's batch. But we are making the real-time predictions, for example. Those are based obviously on observations that we're getting in real time. So those are happening at the instant before the bid requests are sent out. But the adjustment to the decision threshold is done in a batch basis.
Okay, I think there are no more questions, and we would like to thank you very much for your time, and thank you for the very interesting talk.
Thanks very much for having me. Really appreciate it, and enjoy the rest of your day, everybody. Bye.